we don't see any significant steps towards building that ecosystem, right? So this session, I just thought of seeding that idea with all of you. And at the same time, I would like to invite to one of the open source initiatives, which is about building agent framework on JVM, right? So moving forward, so these are the AI trends. If you look at past 5 to 10 years, there has been like machine learning, building statistical models. There have been NLPs, NLUs, and post NLUs, like there was one huge paper or one huge innovation by Google. Attention is all you need. And that's when the whole idea of transformer architecture came into the picture, and people started building something more sophisticated than simple NLP, like natural language processing or the natural language understanding. People did have something like recurrent neural networks, where people were processing natural language. That's where you see the products like Alexa, OK Google, things like that, which were mushrooming at that point of time. But eventually they figured out there's a lot of limitation out there. So that's when the OpenAI, it started off with something else. It started off with reinforcement learning. They had their own framework called OpenAI Gym, and they were going through the reward model to train the models to kind of make the model learn. So if at any point of time, if you feel like you are not able to cope up with the speed or the jargons, please feel free to intervene and get clarified, because it's important to understand. Otherwise, it's of no use, right? So that's when the OpenAI started implementing Google's paper. The attention is all you need. That's when people started seeing a lot of progress and potential in training something as complex as large language models. And according to these trends, we are somewhere in that enhanced narrow UI, capable of more than one task, which can be like the current LLMs or the large language models can reason to some extent, and it can also kind of it has unlimited knowledge because it's been trained like with mostly like 3/4 of the internet or something like that, right? So we are somewhere there, but if you ask me, I think we're already in the general AI, because there has been huge kind of innovations already done by companies like Anthropic with their Haiku and other models, where they are really able to prove like the LLMs are able to reasonably match to the intelligence of human. Like if you look at the CEOs of OpenAI, Sam Altman says like we'll be having AGI, that is artificial general intelligence, in next 5 years. But I think we're already there. The only thing people are not out there is the security and things like how to safely handle AI, how to ethically use AI. These are the things getting people go big way, announcing or building products with AGI. However, we are really in for some interesting times, is what I would like to say. So for starters, in AI, we have like different kind of AIs, right? So there's something called narrow AI, which is mostly like specific to one task. So for example, if you're building an automatic cars, self-driving cars, right? So the AI required out there is to navigate, identify the objects, identify the people, follow the traffic rules. This is very narrow, and it has been given that the model's whole goal is to make sure the driving is smooth, safe, and less often human intervention, right? So that's very specific. So that's what the model would be built for. So that is very narrow. for that model, like it knows like what exactly it is supposed to do and what is its goal. So that is a narrow AI. And we have general AI, which is like more or less like something like human brains, which is able to cope up with all kind of reasoning, observation, thought process, and reacting based on the events, and so on and so forth. So that is what the general AI is. That is like more or less it is going to be kind of um, where we are almost, as I said in previous slide. But the only thing is the security ethics and the validation of how we could use that. And the next kind of an AI is like reactive machine AI. So this is more or less like it responds to an events, right? So it's like you have your system in a state, and on change of state, uh, your AI or the models will react based on the state. Typical example would be your traffic control systems, depending on the traffic, which is on the road or wherever it is. It can be air traffic or otherwise. It can, depending on the state, it can react and use its knowledge to find out what's a probable next state. It's more or less like a pre-trained, and it will not learn from the current environment, but it is more or less reactive on what should be the next state, given the set of states. Unlimited memory is it's an interesting AI where you have limited set of limited amount of knowledge, which is kind of stores it as a context. Uh, a simple example can be any of your website chatbots, not the current day chatbots, like previous version of your chatbots, where it could like kind of maybe able to store the context for up to like let's say like 3 months or 6 months. Say for example, you have raised a ticket with some internet provider yesterday, and if you go like next week, it would be able to reason out that okay, you had raised this ticket and we have solved it, or give appropriate answers for it. But if you go beyond like a month, it may not be having that context, or it may not have that knowledge, like who you are and what was the issue which you had raised previously, right? So that's pretty limited. So that's where the limited memory is. And super AI is like beyond human capabilities and beyond human intelligence, which not only matches human intelligence, but it goes beyond that. Uh, that is where I think the holy grail of AI is what people are trying to achieve. Super AI, I mean, we are very close to general AI, and people are working to make sure we surpass AGI and be super AI. That's where like if you come across all the news like we don't need software engineers, we can develop the code. AI models would be able to generate the full stack code and things like that. How many of you will agree for it? How many of you agree on it? Show of hands. How many of you don't agree? Can someone volunteer and kind of reason out? No, that's, I mean, yeah, I mean, on the lighter note, yes, but then what about, why do you think like software development cannot be kind of taken over by AI? Okay. So the reason I ask this question is like it's a very interesting and controversial question, right? So I really love to hear everybody's thoughts. Like I have my own thoughts. I definitely like to share, but if there are any more thoughts, please do share. Okay, okay, it's an interesting thought though. Any, okay, okay, okay. Mhm. Okay, so my thought is like, if you go back 5 years when Ruby on Rails was on its peak, people were raving about Ruby and Ruby on Rails. The reason is like it was able to scaffold. It was able to scaffold and people were able to build applications in no time. So it was a Ruby on Rails was a darling of everybody's like be it a stack, be it a startup or a medium software company. So why was it? Because people were able to build it very fast and they were able to generate code. So today, I think with AI, I think it's scaffolding on steroids, more or less, right? Because you are able to generate code, you would be able to build applications fast, but whatever code you are seeing is like whether it is trained on something like the code within the GitHub or somewhere else, right? So given that as a point, your models will drift. There is a terminology called concept drift in AI, where your model will change over a period or become stale over a period of time, right? So your model needs to be updated. Of course, that problem is also solved. Like people have strategies beyond reinforcement learning with the large language models. Like we have something called direct preference optimization, which goes beyond reward-based training of a model. So someone said like for the new code, you may not be able to generate from LLM, right? LLMs are going to be getting self-trained, right? So that is going to happen. And people may start saying like, okay, where will we get so much data, right? LLM is going to generate data on which it is going to get trained. That is where the trend is, or that's where the direction is, because at this point of time, even to build something like 7 billion parameter LLMs, it's like it's totally draining the whole internet data, right? So, but if we need to go beyond the current intelligence of LLM to the extent where it is able to kind of make decisions on its own, able to, let's say like if I just say, build me an distributed system to process, let's say MP3 files, right? That's not a simple CRUD application for you to just generate it out, right? So things such as that has to, I don't think right now it is happening. If AI has to build something like that, it needs totally a different way of, training the models or building the models. I believe to some extent, simple applications can be built. If you are familiar with portals like Bolt.new, Versal, they're already kind of able to generate code. And I think one of the directors were put on the LinkedIn. I don't want to name the company. He was going gaga at the fact that he was able to build an Airbnb clone using LLM in 1 hour. But then, I mean, you don't even have to use LLM for it, in my opinion. If you just do the simple Google, you may get these clones. So the answer and my position on that aspect is, yes, it is happening, but we are nowhere close to where it can go or replace a software engineer. That's what I believe. Yeah. So you can use a general models like LLM. There is, Llama. It's from Meta. You could use that. And there is also code generation specific large language model called Code Llama. You could use that. Or if you want to use small models, you could use Quen5. That is also pretty good. Dataset is your code. It is built with the, it has been trained with the code available in GitHub. If you look at GitHub Copilot. Yes. Yes. Yes, it is possible. That's how it is built. Say, for example, if you look at some of the business analytics suite today, where usually what business analysis folks do, either they do slicing and dicing or look into the visualization and things like that, and execute some SQL queries, right? So now it is like if you just give your database with the data, and if you ask a question, Let's say like if it is a sales DB, if you ask like compare the trend of this week's sales with the previous month, same week, right? Your LM is able to make a query on your DB. I'm saying a proper SQL query on your DB, fetch the data and visualize it. We are able to do all of it. So this LLM is trained on the SQL, and it is also trained on the schema. Of course, you need to provide the schema and some kind of a description of your tables. That would make the life of LLM easy. But even otherwise, LLM is able to interpret that. Okay, moving forward. So I was talking about transformer architecture. So I'm not gonna get deep into it, but it would be interesting. Okay, I think to understand. Okay, I don't have internet. Let me connect. Give me a second. Okay, I come back to the slide. I have some interesting visual to show on, say, for example, when you type, "Who are you?" on your chatbot, it clearly kind of visualizes like what happens in a transformer architecture, layer by layer in a deep neural network. That's a very good visualization. Fortunately, I have not got internet. I'll come back to this slide. So yeah, what are GPTs? As I explained, it's a generative pre-trained transformers, and it has been used with, it has been trained with a lot of data. It can be general data or a specific data, depending on what kind of model you're trying to build, right? And moving on, how many of you are familiar with RAG? Retrieval augmented generation. Okay, good. So when do we use RAG? Why do we use RAG? Okay, so should it be organization specific data or can be any data? Okay, so why would you use RAG for organization data? Why can't we use that to fine tune your model? Okay, that's one aspect. So usually with LLMs, it has limited data as of today. Like if you go to a ChatGPT and say like, if you ask the latest real-time news, it will not be able to identify. I mean, it will not be able to answer because it's not trained with the latest data, and the knowledge it has is more or less like what for a period of time which is trained on, and it will clearly say like I have been trained till this 2017 or 2018 data, and beyond that I don't have any knowledge about it, right? So if that is the case, like how do we make use of the current data or any organization data which is proprietary to the organization and at the same time want to leverage LLMs? So that's where the whole idea of RAG come into the picture. What RAG does is like it will augment the data on top of the LLM's knowledge and retrieve the data. So ideally what it does is like as and when you prompt is a piece of text which is in plain English. When you make a prompt, it will go and get usually the RAG. I mean, the data is in the vector DBs. So once a prompt is made, the document which is of similar or which matches to the context of the prompt, we use different kind of algorithms like cosine similarity or various algorithms which could be used, and you can get the document which matches the context of the prompt, and then rank accordingly, and give it as a response to LLM, and LLM will interpret all the documents and score the tokens that is generated out of the document which is the response for your prompt. So it's a very simple flow. You have a massive data set, and AI is gonna take a query and retrieve and respond from its knowledge base. The knowledge base is what your, it can be your proprietary document or whatever it is, right? Moving on, like, how many of you know, like, there were more than one type of RAG? So there are more than one type of RAG. So there are problems with the RAG. How many of you know, like, RAG, when not implemented, is also a recipe for hallucination. It is very easy for LLMs to hallucinate, and there has to be a proper corrective measure and fine tuning of your RAG, like how do you chunk your document, what is the size of the chunk, and how do you kind of set the temperature for your LLM so that it doesn't get itself too creative to hallucinate, right? So we have different kind of RAGs. At least there are 25 to 30 kind of RAGs. I'll just pick top 5, and I have discounted graph RAG because that's the next session. I don't want to kind of intervene in to the next session. So we have standard RAG, corrective RAG, and we have speculative RAG, fusion RAG, and agentic RAG. So for this session, agentic RAG is what the topic of interest is, but I'll just touch through what all different kind of RAGs we have and when do we use what. So corrective RAG is a same flow wherein you have your knowledge base and you have prompts coming to the LLM, and you're going to do all kind of cosine similarities, rank your documents, get the response. Your LLM is going to generate tokens. It will again score on that particular tokens which is generated. And again, there is a corrective. It will look for the generated tokens and to identify how correct is the response generated. So if the response is nowhere close to kind of the expected, or if it is, let's say, like if I ask what is the national sport of India, if it comes back with American football, obviously that's not right, right? So it will try to send back the results, and with the some kind of scoring being chopped off, and then it will try to again do the same cycle until it gets into the right scoring as a response. So that's what the corrective RAG. What corrective RAG does actually is like it will try to correct itself to make sure the correctness of the response is fixed to some extent at least. And we have something called speculative RAG. Again, this is same. RAG as a concept is same, but we retrofit few things. Like here you see that there is a generic LLM retrofitted for a user query. And again, you have a specialist drafter, you have a draft selection. It is retrofitted with more components to speculate like what could be the probable answer and what is it the LLM predicting and scoring, and how is it kind of apt for the prompt received. So if you know that in a transfer model, if the prompt is of like, let's say like 25 words, right? So every time a response to that prompt is generated, every time that 25 plus the generated token is added as a context and pass it for a LLM. So it is very tedious process. So was I clear on that? Like how the prompt always keeps on adding the response for every token generated and then pass it as a context back to the LLM to generate a response. So along with that, speculative RAG has a generalist LLM apart from the actual LLM, which is going to generate the response, and it will compare with both the LLM's response and take a call whether the expected response is up to the mark or not, right? So the thing is, there is also a concept called mixture of experts. So this speculative RAG and mixture of experts and mixture of agents, they all follow the similar kind of terminology where they use more than one LLMs and try to get the best response out of the LLMs and then pass it as score it and pass it as a response. And fusion RAG is again multiple retrievers, and you have individual rankings, and it will reciprocate the rankings and give it as a final ranking. I'll just move fast. And yeah, this is where I believe we need to spend some time. So Can someone give me the definition of agents? I saw like some rise of hands. Yep. Oh, okay. 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 Basically, agent is someone who is synonymous to humans. So we are allowed to have our own clones, right? When you have our hands full, we try to make sure like we wish we could have had someone, who is a clone of ourselves and be able to do the more work, right? So agent is like your personal assistant who's gonna help you, who's gonna be able to reason out, who's gonna be able to come and take your suggestions and finish the task which is assigned to it. It can be as simple as like go and book a movie ticket, or find a right flight for my travel, or just create a travel plan for me for 3 days, maybe like to Switzerland, something like that. So okay, so agents are something which perceives the environment. It learns from environment, and it interacts with the LLMs. LLMs are the brains of agents, and agents would be just like your hands and legs to perform actions. The decisions are done by LLMs. Say, for example, if you go and prompt ChatGPT, like, how do I travel from Bangalore to Ooty? It will say, okay, take a bus, do this, do that, all of it. It will just give you the instructions. But if you say agent, if you just prompt the same thing to agent would be able to get these instructions and ask you back the question. So this is the plan to go from Bangalore to Ooty. Would you like to book me a ticket? Book a ticket for you. And if you say yes, then it will ask like what time, where. It will go into specifics. It acts like your assistant and be able to get your work done, right? So agents are your helpful assistants. And we have multiple kinds of agent, like simple reflex agent, model-based agent, utility agents, and learning agents and hierarchical agents. Simple reflex agents can be as simple as your rule-based engines. Like say, for example, some event happened. Based on that, you have some rules. You apply the rules and be done with it. So it's pretty simple. There is no much rocket science in the simple reflex agents. It just react based on the some event happening in a given environment which it is observing, right? Then we have model-based agents. Model-based agents, all your knowledge is part of a model, which agents will draw the actions it needs to perform based on the event which might have happened in the environment, right? So it can be your sensors, it can be your software agent, it can be your hardware agent. If you are familiar with IoTs, it would be able to give you so like for example, if in this room the temperature is high, and based on the temperature, if it has to act upon reducing the temperature, kind of speaking with the AC. So you can treat AC as an agent, and you can see that the sensors as the state which ACs will observe and set the temperature for the room. I'll just move forward because we have very less time. And we have goal-based agents, wherein agents are given a goal, and then, okay, let's say like a typical example would be return on investment of your social media marketing. Like if you say the ROI for me is like, I need this kind of audience, the target audience are so-and-so, and I want this kind of, what do you call, users to be onboarded in this amount of time, and this is my budget, right? So your agent, let's say like social media agent, would be able to plan like what is the right amount to invest, and what are the channels to invest. Should it go to only advertising? Should it find some influencers on Instagram to make its advertisement more penetrate, right? It will plan everything accordingly, and it will ask for a human intervention in the loop and check, ask like, is it good to go? Can I execute its plan? And go ahead and execute. And it keeps on repeating the whole plan, or better the plan, till it's reached the goal, right? Done. Okay. So there is something called utility-based agent. Again, this is backed by some kind of a utility. It can be a software or whatever it is. Say agent associated with a tool. Like if you're asking to book a flight, your agent should be associated with some tool like say Yatra's website APIs as a function which it can invoke and book the tickets. And learning agents is a bit complex, wherein it will be able to learn from its mistakes and then make sure like it won't repeat the mistakes. So agents as in the concept is same, but it will be able to learn and perform better. And hierarchical agents is like you have a master, you have a slave. It's like divide and rule. Like you have a set of agents, you assign a task, and they will do the task and return the results back to another guy, and you have a supervisor who collect everything and present it back to the human. And there are different levels of agent. I think I should skip. And this slide is where I was mentioning about the ecosystem of AI in Java. It's very important. The whole the way of the software development is going to change. I mean, not because of AI be generating code. It's because the whole architecture, the layered architecture today is like a 3-tier architecture where you have persistence, controllers, models. That will change. You'll get one more layer called AI, where you can have a different way of interfacing your intelligence, the AI bots or agents with your software, right? So today people are just trying to retrofit AI using the UI automation, something like Selenium actions, or people are calling it as simple action models. There is something called large action models. Salesforce just released XLAM, which they say like these are the agents for Salesforce. Yeah, that is going to change. I wish I could have spent enough time here. And agentic mesh is about how do you manage the whole agent ecosystem. Like previously when web services was in Rage, we had all this discoverability and explanation of what these web services are, and how do you kind of um, even identify which web service to be used for what, and so on and so forth. That applies for agent as well. And we have a new concept called agentic mesh, which is going to be um, something like a repository of agents, and agents should be able to kind of explain itself, like what exactly it's what exactly is its expertise in, and how does it communicate, what is the protocol to communicate, and what are the failover scenarios, so on and so forth, and how does it even communicate with another agents. So all of those things comes in agent mesh. And yeah, I think that is all. Unfortunately, I'm running out of time and have an internet problem. I may need another 10 minutes. Shall I? Okay. Yeah, first thing is I need to connect to internet. Otherwise, my demos won't work. SSID is, I guessed, I don't see that here. Hold. Okay, in the meantime, I can take questions if you have anything. Any questions? Not. Okay. Not able to connect. I mean, it's asking for password change. I gave it, it's not taking. This is the username, 8S. We have 0, it is.
Okay. Yes, password.
Give me some.
Zero.
Yeah. Thank you. Okay, thank you guys. I have a very simple demo which I wanted to.
Folks, whoever's laptop is there, please put it back. Hey,
You're so late.
चार्जिंग पे लगाएगा पूरा ड्रेन हो गया ये लैपटॉप
Wi-Fi says it's not yet connected. Yeah. Yeah, I think Wi-Fi is also here. Anyways, fine. Okay, thank you guys. I'm running out of time. If you have any questions, I am around. You can always reach out. Thanks. Yeah. Okay, I think I have 2 minutes to answer the questions. If you have any, fine. So I was trying to show the agents how it is built in JVM, and it's a agentic rack. And I had the another multi-agent demo which communicates between the agents. Yeah, so I would put it across. I'll share the URL. It's an agent framework built on top of Akka. So what the whole idea is, like, we want to, I mean, agents of course need to be concurrent and need to be lightweight, things like that. We feel like the actor model is the best way to build agents. So we are using actually Peko, not Akka, but then people are familiar with Akka than Peko. So Peko is just open source, what do you call, version of Akka. Right? Okay, thank you.